So you do get 2.5 points of extra credit, up to 20. And if you go to all the help sessions, that gives you the 20 points of extra credit, because we'll have 8 help sessions, 8 times 2.5, that's 20 points. Okay. All right. Particular questions you want to look at? We can sort of peruse through them, or expect to see line like number 1, expect to see these types of questions. Yeah, Naz.
I didn't really like number 3, like I watched.
Like you didn't like it, or you? Huh?
I said number 3, like I watched the video and all that, but
Yeah.
I still.
Okay. All right. So what is the net force on Q2? Pretty likely you're going to have a question like this. If not on the quiz, you'll definitely have it on the exam. So I want to know the net force on Q2. This is a superposition problem where I'm adding up 2 forces and I have to do the vector sum. Although this is just one-dimensional, so it's not as difficult as the 2D. So first I'm just going to draw the force vectors. Notice this is positive, and this is positive. So I'm going to have 2 repulsive vectors. Let's do due to Q1. So I'm going to have a force vector in this direction. I'm going to call that F12. The force due to particle 1 on particle 2. And then I'll call this other one F32. But let's be careful in the way that I draw these, because if I do it well, I can probably not do any math at all or any computations. Remember, F is equal to K Q over R squared. Good morning. So F is equal to KQQ over R squared. Notice that Q3 is 4 times as big as Q1. So I'm going to put a 4 right here, because 8 times 10 to the minus 4 coulombs is 4 times that of 2 times 10 to the minus 4 coulombs. Do you agree? Follow that? And then also notice that the distance, 4 meters, is twice that of 2 meters. So I've doubled that distance. So the force that's due to this charge is going to be a factor of 4 over 4 times. That means that force is going to be equal to F12. That is, F32 will be equal to F12, and so the answer here is 0. If you don't get that, and you're not sure about how to deal with those relationships, like if R changes, if Q changes, then you can just calculate F32. F32 is K times 8 times 10 to the minus 4 coulombs times 4 times 10 to the minus 5 coulombs divided by the distance squared. Hey, good morning, Octavia. Divided by 4 squared. And then you can find the values for F3 and F2. And then once you find the values, for F32 and F12, once you find those, to do the sum of the forces, you say F12 minus F32. And you'll find that those will be equal in magnitude, and so that answer would be 0 newtons. I don't know what that number is, F32, but it is whatever it is. It's, let's see, the 4 cancels, 2 times 10 to the minus 9. It's 18 newtons, I think. And then the other force is also 18 newtons. Yeah, Lily?
Can you repeat what you said about quadrupling the Q?
Yeah, so when I look at these 2 charges, like first I imagine this force. That's due to this charge. Now what happens if I quadruple the charge? That's what I did right here. That is Q3 is 4 times that of Q1. And what happens if I double the distance? That is 4 is twice that of 2. And so if I quadruple the charge and double the distance, I get a 4 in the numerator, and I get a 2 squared in the denominator. That's 4 over 4. So that means that the force, F12, has to be equal in magnitude to F32. That's the way I prefer you to do this, because you're not dealing with numbers, and people make mistakes when they deal with numbers. And, really I prefer that you take the whole exam with no calculator at all. And most questions you can do that, even the ones that look like you need a calculator. Because, I don't know, I just prefer you not use a calculator. But some you do need calculators on. but on this one you do not. Okay? Now, it was probably the first way that I did it that you didn't really get that, right? That's the most common way not to get. I mean, you're probably pretty good at putting in the numbers and figuring out the force, right? Because y'all are okay with this, right? Like KQQ over R squared. Good with that? Okay. Remember K is, that's that 9 times 10 to the 9th. But it is that second way that I really want you to do it. That's the easier way. Once you understand it, that's the easier way. And you do need to, by the way, know how to do this whole gymnastics, because that comes up, for example, in number 4. Can we do number 4 while we're here? Number 4 is not easy either, because what I have here is very similar, actually. I have a charge S, and there's a force of 16 newtons due to that charge Q. And then I ask, what is the direction of the net force on S? Well, in order to find that direction, you first need to find what is the force due to the 2Q charge. So I'm going to write Coulomb's law. F equals equal to KQQ over R squared. And then notice that I've doubled the charge. That is going from here to here. I've doubled it. And what have I done to the distance going to that 2Q? How have I changed the distance going from 4 to 2 meters? I've halved it, right? So I have a 1/2 right here. So that means I have a 2 over 1/4, or I have 8 times the original force. So if I were to draw the vector here, well, it would be really big. It'd be 8 times that vector. That's not really to scale. It needs to go further down. But you get the idea that that vector is a lot bigger. Now, if I think about my vectors and how they fall on my coordinate system, they're going to look like that. And I want to know what is the angle of the resultant vector. I'll call that theta. You can do the whole inverse tan of opposite over adjacent, or you could probably look at these and tell me what the answer is. Or at least you could look at them and rule out several answers. I can rule out the C, right? Why can I rule out C? It's above, and this one's definitely below the positive x-axis. So I can get rid of C. I can get rid of 2 others immediately. What are those? 45 and 32, but I also get rid of 20. You'll see why I can get rid of 20? Because I know that this angle is 45 degrees, and so the angle has to be bigger than 45 degrees. 45 degrees occurs when the 2 components are equal to one another, but here the y component is bigger, so I know that my angle is bigger than 45 degrees. So I get rid of that, and now I'm stuck with either 53 or 83, and you would probably rightly guess that it's what? 83, right? Because that x component is so small compared to the y component. So E is the right answer, but if you're not sure, you just do the inverse tan of opposite over adjacent. That would be 8 times 16. What's that? 80 plus 48. 128 divided by 16, and you would find that it's equal to 83 degrees. That's just finding the angle with my inverse tan. Y'all had 201, right, Juliana? The 3 of y'all did. Glacia and Haley, y'all had 201. Y'all did vectors, right? Yeah, quite a lot. Yeah. Oh, you took it over the summer? Okay. We all did all this. Y'all did vectors, right? Okay. All right. Be prepared to do this whole thing where if I change the charge, change the distance, what is the new force? Or what is the new electric field? Y'all should know, if you've been practicing, and I think all of y'all probably have been practicing, then you've probably seen those types of questions. All right, what else? Is this exam or some other exam or maybe just some type of question? I'm just going to sort of scan down through here. By the way, notice that you will stop at one point. In this case, when you get to anything that says it has to do with potential. So like you would stop there after 14 and not go further, because your exam 1 will cover chapter 1 and all or part of chapter 2. So you don't have to worry about all of chapter 1, all of exam 1 rather. Particular questions you want me to work through? All right, well, let's do, y'all are thinking, but I have a particular question I want to do. Or particular type of question, let's see. Oh, let's do one like this. Is this oh, this is not a conceptual. Oh, we'll do it anyway. So let's look at number 12, and then we'll look at the other kinds. Here I want to know what must x be for the electric field at A to be equal to 0. This is probably one of the most difficult questions on this exam. So I want to know the electric field here, or rather I know that the electric field here is 0. Let's call this charge 1, and we'll call this charge 2. By the way, do y'all know what exam is this? Well, it's actually spring 20. I might have called it fall 20, but that was an error. Anyway, so that's charge 1, and that's charge 2. And so the electric field due to charge 1 is in this direction. I'll call that E1. And the electric field due to charge 2 is in that direction. I know the directions because I imagine that there's a positive test charge here, and a positive test charge is repelled by that charge and attracted to that charge. So E1 is to the left and E2 is to the right. Yeah.
Are you always going to assume that your imaginary test charge is positive?
Yes. Yeah, that's just what your imaginary test charge is. Nobody walks around with a negative imaginary test charge, right? Who has a negative imaginary test charge? Nobody. Yeah, it's always positive, yeah. That's just how we define electric field. There's no reason for that. It's just the way it is. All right, so I know that in order for the electric field to be 0, that E1 has to equal to E2, the magnitudes of those. Okay, so let's just set those equal to one another. That's going to be K times 2 times 10 to the minus 9 coulombs divided by my distance, which is 2 meters squared. And now I'm going to set this equal to K times 18 times 10 to the minus 9 divided by, now this is the tricky part, because my distance is from here to here. And so that distance is what? How do I express that distance? Yes, thank you, Juliana. 2 plus x. That is going to be, I'm going to write as x plus 2. And then that's squared. And now I need to solve this for x, which might cause you to freak out a little bit, but just start simplifying things. Because, well, I have a distance 2 here and a distance x here. And so I treat that x like a number, or it's a variable, it represents a number, and I say it's equal to x plus 2. I can get rid of the k's here and here. I can get rid of this 2 with one of these two. So I'm really left with 1 over 2 equals, I meant to get rid of that, is equal to 18 over x plus 2 squared. Oh, and this is convenient because look, 18 times 2, that's 36, is equal to x plus 2 squared. And then I can square root both sides, and I get 6 equals x plus 2. So this is actually working out quite simply. And so then x is equal to 4 meters. So that's the answer for that one. So a couple of points here is that, E1 had to equal E2 in order for the electric field to be 0. And then there was a little bit of algebra going on here, but then it turned out, just because of the numbers that I used, that it wasn't that complicated. So don't freak out if it looks like it's going to be complicated. Just take a big deep breath, right? Y'all ever do that in the test? Just, do you? Yes. That's very good practice. Like, if you get really frustrated, take a big deep breath and, try to sit back, write down everything that you know, write down what you need to know, draw a picture. If you're still frustrated, just move on to something that you know how to do, and then come back to it. Put a big star next to it. Yeah.
Do we have any examples like that where humans were not equal to each other? Or in any case they will have to be?
Like where you would find x?
Yeah.
No, I mean you have to know what they are in order to find that unknown variable x. Now there are some examples where we have 2 charges, and I just want to know what is the electric field at that point. We can do one of those, but I want to do another one that's like this but qualitative first. That's really what I was looking for. Is that okay? Okay. Let me go back up to the top. I'm sorry. I'm fishing for something. We'll do this one. This has to do with force. And I want to know where can I, we've done this problem in class, haven't we? We've done this one in class, I'm pretty sure. Yeah. I know something really similar to it. Okay, let's do number 9 here. This is similar to the one that we just did. Here I want to know, where is the E field of these two charges equal to 0? All right, so first of all, I want to figure out where in relation to the charges is it possible for the E field to be 0. So I can just start fishing around and say, well, what if it's over here? I have an electric field due to this charge. I'll call this charge 1 and charge 2. And the electric field of charge 1 is going to be in this direction. And then the electric field due to charge 2 is going to be in the opposite direction. And that's a bigger charge, but notice that it's also a further distance away. So it's a bigger charge, but it is a further distance away. So I can have a possibility of having those two electric fields be equal to 0. Whereas, say if I'm somewhere in between here, I have an electric field due to the, let me do it over here. An electric field due to 1 is going to be in that direction, and then E2 is also going to be in that direction. So it's not possible to have an electric field equal to 0 between the two charges at all. Nowhere between the two charges. And then similarly over here, if I draw the electric field due to the second charge, I'll draw it like that. The electric field due to charge 1 is going to be to the left, but is it going to be bigger, smaller, or potentially the same as E2? Let me repeat that. So I have this electric field. Is the electric field at this point due to this charge bigger, smaller, or the same as the vector that I just drew? Potentially the same. A lot smaller, right? Because this is a really big charge. This is 1/9 of that charge, and it's farther away. So Q is small, R is big. That means that my electric field is going to be really small. So I'm going to draw E1 like that. Not possible for that to be for anywhere to the right of the 9 coulomb charge. So I can get rid of that one. And then I can also get rid of that one. So it has to be either B or C. Either 1 meter to the left of the -1 coulomb charge, or 3 meters to the left of the -1 coulomb charge. Okay? I've gotten it down to 2. That's pretty good. Like at this point I can guess and have a pretty good chance of getting it right. I'm going to erase these. Alright, so now, let's see what I'm doing. I want E1 to equal to E2. That means that Q1 over R1 squared should equal to Q2 over R2 squared. Now, Q2 is 9 times that of Q1. So the distance between this point and Q2 should be what factor of the distance between that point and Q1? As if I want these to be equal, I have a 9 right here. R has to be bigger or smaller than R1 by what factor? Somebody's about to say it. I can tell you're thinking it. What are you thinking? Guess? Can you guess? 3. Yes, 3. because 3 squared is 9. So my distance R2 has to be 3 times the distance R1. And which of those answers will give me a distance that is 3 times? 1 meter or 3 meters to the left of the minus 1 coulomb charge? Huh? 1. Right. Let me show you why. So if I have this distance is 1 meter, well, this is a tough question too. Goodness, this is your toughest exam this semester, okay? Exam 1 is your toughest. I always say that, right? And then it is really, though, like historically, like people tend to do, this is their hardest exam. So if 1 meter, that means that R1 is equal to 1 meter, and that means that R2 is equal to 3 meters. Look, R2 is 3 times R1. It's the easiest way to approach that problem, by far, is to set it up and then ask about these ratios. Okay, somebody had asked about an electric field problem where I'm actually doing numbers, right? I think, Lily, was that you that asked about that? Yeah. Let's see. I don't know. I have one right off that is like that. But I know I have electric force problems that are that way. We go back to S18, is that right? Spring 18? That's what I said, right? 18, 19, 20, 21, 22. Yeah. I'm not seeing one like that. I don't think I asked questions like that, at least not in the last 5 years, just because it's sort of the same process that you do when you do the 3 charges in a row and ask what is the force, where you're adding 2 one-dimensional vectors. This is a problem, though, that's good for you to know. If you go back, the last couple of years, your 2D problems have been in the free response. But if you go back to the earlier exams, you'll find some where the 2D problems are in the multiple choice. So I would be looking for those because you're going to see those on the quiz. Like, for example, number 7. I want to know what is the magnitude of the electric field at point A. In order to do this, and then I think there's a follow-up question, yeah, what is the direction of the electric field? So this is just like we did in class with the 2D vectors, but it's multiple choice and not free response. For your exam, you'll see it in the free response, but for the quiz, you'll likely see it in the multiple choice. All right, so I'll call this charge 1, charge 2, and so E1 is going to be in this direction, and then E2, which is half the distance, but a quarter the charge, so I think it's going to be equal, right? If I'm thinking right. Yeah, so E1 and E2, I'm just trying to draw them relative strengths together, or relative lengths, so that they're with proper relative length to one another. So those are my 2 vectors. Oh, I drew that wrong. Somebody catch that? Yeah, thank you. Not always right, am I? All right, so E2 is in that direction. I can calculate E1. KQ over R squared, that is K, let's go right in the numbers, 9 times 10 to the 9th, 8 times 10 to the minus 9. Notice I'm not putting in the negative there, I'm just finding the magnitude, and the distance is 4 squared. Those cancel there, the 8 cancels with 1, leaves a 2 there, and I get 9 over 2. That's equal to 4.5 newtons per coulomb. And then E2 is equal to 9 times 10 to the 9th times 2 times 10 to the minus 9. I'm just doing KQ over R squared divided by 2 squared. Those cancel. This cancels with one of these, and I'm left with 9 over 2, and so that's equal to 4.5. Yeah, they are equal. So I have those two equal electric field vectors. In order to find the magnitude of those, I do the Pythagorean theorem, 4.5 squared plus 4.5 squared, 6.4, I think, right? So that's the answer, 6.4. I know it's 6.4 because the hypotenuse can't be less than any side, so it gets rid of those two. And then 16 and 9 are just, those hypotenuses are just too big for the two legs of that triangle. But you can do the calculation there just to determine that. And then the angle should be pretty easy. I'm going to redraw it up here. I have two vectors. One is up here, one is right here, so the resultant is right here at an angle of 45 degrees. So I know A and C and D and E, none of those are right. I just check my reference point. It is above the negative x-axis as it should be, and so that's the answer B. Okay? You won't see anything like number 9 because it has to do with potential. We'll see that next in the exam. Okay? You're going to see some 2D problems. I'm not saying it's going to be that one, but there are others that are really similar to it. All right, so you'll see two-dimensional problems where I'm asking you to calculate the electric field or the force in 2 dimensions. Okay? Be prepared for that. Notice, by the way, that this problem is quite a bit easier than the one that we did in class. Why is it easier? What did we not have to do in this case? I didn't have to resolve the vectors, right? And that makes it, adds another step that's, makes the problem quite a bit easier. Alrighty? Alright, other particular problems or types of problems that you want me to work? Lily, you look like you have a question. No?
Number 5 at the beginning, are you going to ask for any units other than electric field? Or any other questions like that asked in physics?
The units of the electric field? Well, I'm only going to ask you what's in the first 5 years. So whatever unit questions I ask, right? All the questions on your quiz come from the first 5 years. So I think usually in these exams, I usually just ask the units of the electric field. I also would not ask you any unit problem if the answer was volt per meter. I know we've presented that, but we haven't really gotten into volts and what that means, so I wouldn't give that to you right now. The electric field units can be newtons per coulomb, or later in chapter 2, we're going to see they could also be volts per meter. But we haven't gotten into potential. I guess we'll do that today, get into potential, huh? Whoop! I'm excited, right? Chapter 2. And in chapter 2, we get to see circuits. We begin to see circuits and capacitors. That's exciting. Yes. Okay. What else, y'all? I'm here to answer your questions. So, y'all know how to do number 7? I think we're going to do this in class today. Yeah, we are in class today. Let's go ahead and preview it. So if Q1 has a magnitude of 3 coulombs, what are the sign and magnitude of Q3 if this is 3 coulombs? Now, let's imagine a dipole. Let's say that I have a charge here of 1 coulomb and a charge here of 2 coulombs. When I draw the electric field lines, we're going to say this is negative 2 coulombs. When I draw the electric field lines like this, I'm going to have extra electric field lines going into the bigger charge, so that the ratio of field lines here to here is the same as the ratio of the charges. See how the ratio of the charges is 2 to 1? The ratio of the number of field lines is 4 to 2. So those ratios are identical. I have a 2 to 1 ratio for my number of field lines and the charge. Bigger charges, more field lines. The more field lines represent that I have a bigger charge. I have a bigger electric field, and a bigger charge carries a bigger electric field. So in this problem where I have 3 charges, well, the easiest way in this one is to say, well, I have 3 coulombs, so I'm going to let the 3 lines represent 1 coulomb each. So then Q2 would have a charge of what? 5 coulombs, and Q3 would also have a charge of 5 coulombs. And Q3 would be positive 5 because the field lines emanate outward from positive charges and go into negative charges. We're going to do that today in class, but when we're doing the electric field mapping. All right? Other questions? It's useful for y'all? Yeah? All right. I want a really good showing on the quiz, right? What do I want on the quiz? 100%. And you can do 100%. Like, even if you're finding this really difficult, but for the quizzes, it's really just brute force. You know, because they're only about, well, 5 times about 13. They're only about 65 questions or so for you to know. And really, a lot of those are sort of repeats of one another. So brute force, like, you can just, even just memorize all those questions, I'm okay with that. All right? For the exam, you can't really do that because the exam has different questions. But in the course of memorizing those questions, if that's what you choose to do, I really prefer that you understand. Like, that's always the better way. But in the course of memorizing, I think you'll begin to build that knowledge and skill. All right. If you came in